small beads having positive charge 5q and 3q are as opposite ends of the horizontal insulating rod of length 2 meters. The bead of charge q1 is at origin, and definitely this will be at 2, 0. The third charge is free to slide. So at what point x is the net force 0? So net force 0 means the electric field should be 0, right? The electric field due to the charge 1 is going to be F1 over here, because they are positive charges, and because of Q2 it's going to be F2, I mean E2 over here if you're talking about electric fields. What is the electric field E1? That will be K q1 over x, because the distance is x over here, which we x square, which we have to find, and e2 magnitude is going to be k q2 over 2 minus x whole square, because this distance then will be 2 minus x. Both should be equal, right? Both should be equal. It means that k q1 over x square should be equal to k q2 over 2 minus x whole square. This k and k is cancelled. Q1 is what, 5q, x square remains as it is. Q2 is what, 3q, so that will be 3q over 2 minus x whole square. As q and q is cancelled from both the sides, if we cross multiply, then 5 times 2 minus x whole square is 3x square. If we take square root both sides, then root 5 times 2 minus x is equal to root 3x, and all we have to do is find x. uh, uh, okay, we have to find x over here. So if we open the parentheses, it's 2 root 5 minus root 5x is equal to root 3x. Adding root 5x both sides, we have root 3x plus root 5x, so that will be equal to 2 root 5 will be equal to root 3 plus root 5x, and dividing both sides by root 3 plus root 5, the value of x will come out as 2 root 5 over root 3 plus root 5 meters. So that is the exact answer. But if they are interested in the decimal approximation, that's also something which we can give. Root 3 plus root 5 and 2 root 5 over this value comes out as 1.13 meters up to 2 decimal places. Thank you.